You're listening to a Pop House Network podcast for developers by developers.
Welcome to Java Pop House episode 98. Hey everyone, this is a very, very fun episode because a lot of things have happened with the Java ecosystem, and the big thing that happened is that we finally hit another huge milestone with the LTS release of Java 17. My name is Freddie Guime. I'm one of the hosts here, Java champion, speaker, author, Seattle Java user group organizer. I'm here with my usual suspect, Bob.
Hey everybody, Bob Paul, an independent consultant from Chicago, Apache Software Foundation member, Java champion, speaker, and CJUG board chair.
And today we have a very special guest who you should always know about him because he will deprecate you if you don't. Stuart.
Hi, this is Stuart Marks. I work at Oracle on the OpenJDK. I am the Java JDK Core Libraries project lead. And as Freddie mentioned, my alter ego is Dr. Deprecator. So I have a bunch of stuff we can cover today, but there is definitely some deprecation material to cover here. So we'll make sure to include that.
No, definitely, and that is one of the things. Like it's kind of funny because I still remember deprecated was like, oh yeah, it's deprecated, nobody cares, and then it was deprecated for removal, which was okay. Now where things are getting serious, and finally, Dr. Deprecator is doing the thing that he always wanted to do. Is removing things. So it's gonna be good. But we're not gonna be talking about just removal. We're not gonna talk about all the fun and exciting parts that are part of Java 17. So
yeah, and I think the last time we had Stuart on to talk about languages was the last long-term release. I think it was it 11? Does it go all the way back there?
Yeah, I think so. And in fact, if I recall, you guys said you should talk about JDK 11. And I said, well, since most people are upgrading from 8, we should also include 9, 10, and 11, because there was a ton of stuff in those releases. And so here we are again 3 years later, talking about 17, but not just JDK 17, but everything in JDK 12 all the way up through 17. And there's a lot of stuff. We had to cut out a lot too.
Everything's on schedule though. That's the rub though. Maybe we didn't get everything we thought we'd get 3 years later, but the releases are on time. This has been amazing.
I tell you, this is a big change for me after N decades in the industry. Actually being on a project where we ship releases on time is quite unusual.
It's what is this feeling?
I look at all the previous stuff. It's oh, we got to slip the schedule over and over and over. But yeah, we don't do that anymore. It's pretty cool.
No, that was an amazing change. And we're we get toys earlier. That's the thing that happens. For us on the other side is oh, what do we get to play on this new release? So it's fun. And talking about things that we're gonna play in, we're gonna let you just drive it. So we'll be I'll be the little dumb guy that is just gonna ask questions as they come on. So
well, let me ask around. So Freddie, do you have any clients on 17 yet, or that are thinking of upgrading to it?
So there is there's actually 3 projects that I have my hands on. One of them is relatively small, but the other 2 are a little bit of heft, and we just want to see just doing, because one of the fun things is just dropping in the new JDK and running it on the new version, even if you don't change one line of code, usually comes with performance improvements. So that is one of the tests that we're going to be running probably just in the next month. Just to see, do we get anything for free? Since it's another LTS release, there is a lot of appetite for, let's just give it a shot and see what it looks like.
Yeah, no, similar. I've got one client that picked up 16 a little bit early, just to kind of kick the tires as a pre-release to 17. And same thing. Did not adopt a lot of the idioms or the things in the language at that point. It was, hey, let's pick it up. Let's see if we can get current. Let's see where the edges are. And frankly, it was relatively painless. So another kudos to that. Once I got to 11, it was much less painful.
It was
getting to 16 and above.
That was the hard part.
Yep.
Actually, while we're on this topic, I'm wondering if you guys know how many, what part of the user base is still on 8 and are going to skip directly to 17? You think that's going to happen a lot, or people are just going to go to 11 now?
I think yeah. So we do have other projects that are on 8 that and it's one of those where if you're going to have we're sort of like back talking, like if you're going to have the pain of upgrading to 11, why just go all the way? Like there's no reason just to stop there anymore. And there are some. I think one of the things that is pushing is this idea that I think technically like 8 is not necessarily like end of life, but it is one of those where I think that because it's two LTS I guess behind, then it's we do start getting worried. It's like it is time, and then this is actually a PSA for everyone who's still in 8 that there are options out there for keeping up to date with old patches and stuff. But usually, if you get too far away, it's going to hurt too much to upgrade, and it's going to be even more painful. So this should be the time.
I'm seeing, I guess, in the places that I dabble in, is a lot of the libraries, open source libraries, proprietary libraries, are starting to drop support for 8 in lieu of 11, in lieu of knowing that 17 is coming. So in interest of staying current on your libraries for security patches, not in the JDK necessarily, but in my client dependencies and transitive dependencies, there's been, I think in the last year, a bigger movement to 11 from 8, since a lot of the libraries still support 11, even as they're kind of moving on to 17 with that coming out. Mm-hmm. So, I mean, my big moment on my desktop was when Eclipse dropped support for 8 and said, hey, we're on 11 now. It's like, well, I guess the default JDK for my desktop is now 11 because my IDE is there, and I don't like disappointing my IDE because it's buggy enough.
You take care of your tools.
Yeah, no, I take care of my tools. And the beauty of it was Maven was already ready for it. A lot of the other libraries were already ready for it. So it really wasn't that big of a deal to upgrade my desktop. I still have 8 installed for some of the projects that I work on that are still 8. But in the grand scheme of things, the majority of my desktop and projects now are 11 or above.
Nice.
All right. Well, okay. So should we just dive into some of the language features?
So let's talk about the language features. I mean, we've kind of broken it up. I mean, so there's a couple of ways to look at it. There's the way to look at it from, where the things are occurring in the JDK. And then, there's the way to look at it from, the developer cross sections. What am I getting for performance? What am I getting for syntactic sugar? What am I getting? What am I getting rid of? So we've kind of broken down the categories like that. And language is, I think, when you look at the lineup of features, is the heaviest part of investment when you're talking from 11 to 17, at least on paper. If you look at the JEPs and kind of the change that you see there, a lot of language stuff. I mean, Stuart, do you have an opinion on that? I mean, where do you think that
I think there's definitely a lot of investment in language evolution. There's you probably you and our listeners have probably heard about all the big projects that are going on. There's Loom, Panama, Valhalla, and Amber, and So those are, I mean, those are all still going on. They're all making progress, but mostly they're off to the side. However, the one that is actually delivering features incrementally into the regular JDK releases is Project Amber. And so that's where, in fact, I think if you look at the language features that we've added between 11 and 17, I think they're all parts of Project Amber.
Mm. Yeah.
And so did you want to just dive into the particulars of them?
Yeah, let's dive into so I mean,
yeah.
One of the things that I always run into is if I'm doing some class matching, if I have to check the type of an instance of something, the very next thing that I'm going to do is I'm going to need to cast it to that object or have to deal with it on that level. So the JDK, there's a JEP that kind of addresses that use case with some shorthand notation in order for me not to have to do that cast anymore. And that's the pattern matching, correct?
Right. Well, so this one is pattern matching for instance of, and so it's a specific case of pattern matching. And so it's actually this by itself is quite a small language feature, and it's intended to address exactly what you just said, Bob, which is, if you sometimes somebody passes you an object and you want to say if it's, if object instance of string, then the very next thing you do is you downcast it to a string and then maybe assign it to something. So then you say string s equals, cast to string of object. And, or sometimes you just put all the parentheses in and use that directly in an expression. And, so pattern matching for instance of, since you've just did the instance of check, what it does is it declares a new variable and conditionally assigns it if the instance of is true. And so there's a lot going on there, but it's actually very simple. So you can just say, if you have an object and you want to test if it's an instance of a string, you can say if object instance of string s. And then right there is a new local variable s that's been declared that is a string, and it does the downcast for you. And then from that point on, you can use the variable s. Now, what's interesting about that is, it's a pretty small feature. So it cuts out the boilerplate of you having to,
recast,
to do the cast yourself and then declare, and also to declare a separate variable, on a separate line. And, but what's nice about this is that the scope of this new local variable is only from the portion of the expression or the if statement where it is in fact known that the object is actually an instance of a string. So the typical way is you say if object instance of string s, open brace, and then within the braces, that condition is true. So then the s variable is a valid string. But outside the braces, that variable is no longer in scope.
So it's like your for loop where you declare like an int when you're going around. So old school for loop, that int variable, that counter is usually what it's used for, is available inside the for loop, but not on the outside of the for loop. But I still have to worry about my scoping. So if I scope another string s outside of that instance of, I should get a compile error, correct? Because I have two variables scoped to that. Yeah,
you can't have two local variables with the same name and have one. Oh, I forget what the JLS term is for this, whether it shadows it or obscures it. I think those actually are technically different. But you can't have a nested scope with a duplicate variable name among locals. But I think a local variable can shadow an instance variable, for instance. So you have to be a little careful there. But yeah, it is declaring a new local variable, but the scope is exactly the areas of the code where the value is valid. And so I think, though, the thing is, this is a really small thing and it's useful. And in fact, we did have one of our team members go through a bunch of the code and replace all these casts with uses of this new instance of expression. And, it was kind of nice. It cleaned up the code a little bit. But I think it proved the value of it. But I also think that this is, by itself, this isn't the biggest feature in the world. And in fact, if this were the only thing we ever did, it probably wouldn't be worth it. And I think the point here is that this particular language feature is the first step in a whole new series of features having to do with pattern matching. And so, for those, I think Brian Getz and Gavin Bierman have done a whole series of presentations on these in a whole bunch of different places. I can certainly dig up some links to put into the show notes. But basically, there's a whole series of features that they have planned around pattern matching. And so I think matching on a type is just the first step. Well, matching on a type and then binding to a variable. That's the smallest step forward. There's a whole bunch of other stuff that will come later on. Some of it is preview in JDK 17, but more of it is planned for later releases, where they can do not only pattern matching, but pattern matching and extraction, and then nested pattern matching, nested pattern matching and abstraction as well. So there's a really nice story, and this is really only the first step in that whole story.
I see. So this is just laying out the work for bigger things to come as we go with pattern matching for the next version of the JDK then.
And is another one of those things like the switch expressions, which is another kind of additive change with 14.
Yeah. And so again, I'll refer you to some talks that Brian Getz has given, but he talks about a long-term plan to rehabilitate the switch statement. And so just a quick recap here. Switch is prior to, I forget when we delivered this particular feature, JDK 15 or something. But prior to that, switch was a statement and it did only control flow. And so you said switch on some expression, which evaluated to a value. And then there was a branch to a case label. And then it would start executing statements from there until you ran off the end or you return or break or something like that. And so it's very much control flow oriented. And and that's fine, but there are a bunch of, it's a holdover from C. If you're an old C programmer, it's very similar to the C switch statement. And of course, C is, the whole point of C is to be close to the machine model. And so a lot of C programming is very low level, for good reason. But in Java, we found that Switch had a bunch of problems with it. And the classical one is you forget to put a break statement in. And so you fall through to the next case. And sometimes you want to do that. It's actually really rare. And so probably if you fall through to the next case, it's more likely to be a mistake than actual intent. So that's one thing. Another thing is that people would write highly stylized switch statements where it's like, all right, so I have, I have some value I want to switch over, and depending on what value that is, I want to assign, some different value to a local variable. And so what you have to do is you declare a local variable, switch on some value, and then in each case statement, you make an assignment to that local variable. And that works okay, but there's, keep referring to Brian Getz here. This is a place where bugs love to hide. I think it's a great line because it's true, right? I
steal that all the time.
Yeah.
Yes.
It's really true, right? So consider if you have a switch statement that does an assignment in each case arm. If you forget to put a break, then it falls through to the next one, assigns the wrong value, and then continues. And no warning or anything. All you do is you get the wrong value and then something goes wrong in your logic later on. And it's like, why is it doing this? Right. So, or if you, there are a variety of other mistakes that you can make writing out a switch that way. So anyway, Okay, so the first step in rehabilitating this switch statement is to say, this kind of switch statement is so common that what we want to do is turn a switch statement into a switch expression. And so this is kind of weird. There are other languages where every program construct is an expression that evaluates to a value, and so this is actually fairly rare in Java. But the idea of a switch expression is that it's very similar in that it evaluates some switch value and conceptually branches to a case label, but what's in the case label is not necessarily a series of statements. The case label identifies an expression, and that expression is evaluated, and it's the result of evaluating that expression is kind of the return value of the switch itself. So if you wanted to assign a string to something, instead of saying string s and then say switch on some value, and then in each case you say s equals this or s equals that, you say string s equals switch on some value. Then you can say, case 1 colon. Wow, sorry, the source code is a little too hard to visualize here, yeah. But basically you don't have to put a statement after the case. You can just put an expression. And so maybe that's a string literal, or maybe that's some method that you call and return a string or something like that.
So you're down to just the single assignment. And I mean, looking at the JEP itself, I mean, it looks like some of the notation is borrowed from lambdas, which I think follows where you've got just, hyphen and then arrow symbol into the switch statement rather than the break lines. You can put brackets in there and have multiple things potentially happen and then return. So, I mean, it's some stylistic changes, but also, again, trying to eke out some of those cases that create bugs.
Right. And I think one of the main things is that it's again, a very common problem with switch statements is that you can have a case missing. And so if you omit a case, and you don't have a default, then basically it just skips over the whole statement and continues. Right. Whereas with a switch expression, now one of the a very significant difference between a statement and expression in Java is that an expression must have a value. And so, since that's true, the switch expression, it has to be what we call exhaustive. So if you provide a value to a switch expression, then you need to provide a case that handles every single possible value of that expression or a default. And so that's another way, right? So if you ever written a switch statement that wants to make an assignment in each case arm, but you forgot to handle a value, then again, you have the same problem where, your variable ends up with an unexpected value later on. And, then you got a debugging session ahead of you. Oh, so the switch expression makes sure that you handle every value that can possibly come in. And because it has to have a value that's going to be the result of the switch expression that gets made in your assignment statement or in a return statement or something like that.
So ways of limiting values, is that typically like come out as an enum where I do have a fixed set of values, or are there other ways that I can get a fixed set where I don't have to do that default statement? I don't remember offhand exactly what those are. I mean, I think enum is the classical case. I think all the others you have to provide a default statement. I was wondering if they had gone so far. Oh, Boolean, I think, but you wouldn't use a Boolean. I didn't even know if you can switch over a Boolean, quite frankly. You're using the wrong kind of statement, probably. Yeah, if you're doing that.
I was wondering if you could do this with byte, for instance, since there are only 256 possible values of a byte. Oh my God. But no, I don't think they do exhaustiveness checking on a byte, right? So if you write out all 256 case arms, then it doesn't save you much not to have to write default. So I don't think they covered that one. I actually tried that one at one point. I think I wrote a program to generate all the case arms, right? Because I'm not going to type them all in.
Gosh, it's so funny because like so many day or so many nights just trying to troubleshoot. Like somebody added a new enum somewhere, and it just went into a default case of a regular switch statement. Because like one of the things that I remember like explicitly is like I will not add a default because I want this switch to be exhaustive, and I want this thing to break if somebody adds a new enum, or like a way to essentially protect myself in case somebody else added something to the enum and it's something that I need to take a look at. This will make it a little bit more clear as well in terms of like where is it and just being exhaustive on the expression. So yeah.
So I think it's a good leading question though, Bob, because I think right now enum is the primary type that does the exhaustiveness checking. But the next feature is sealed classes. And it's not quite there. Well, sealed classes are there, but the exhaustiveness checking for switch is coming up in the future. But this is a good setup for it because sealed class is kind of an interesting feature that it's useful a little bit today, but its usefulness is going to improve greatly in the future. But basically, let's describe what this is. So imagine you have a class hierarchy, and you want to have like an abstract superclass, or you want to have an interface, and you want to have a fixed set of subclasses or implementations that are under your control. And so, for a variety of reasons, you might want to, for instance, define an interface and then have like three classes that implement it. But in Java, there's no way to prevent somebody else from creating an implementation of a public interface. So if you do want to limit subclassing, what you have to do is you have to do something like create an abstract class, put it in a package, and make sure all of its constructors are package private. And then make sure that all of your subclasses are in that package. That way, nobody outside the package can subclass it. And so what you're doing there is you're actually creating, it's a little type hierarchy, but this is a kind of a, let's see, is this right? It's an algebraic data type. It's called a sum type because it can be, if you have three subclasses, it can be this or that or the other and nothing else.
Yeah.
And so they're unified by a common supertype. But the language has no way to express that. What you had to do is use the language's access controls and whatnot to prevent a fourth subclass from being added. And so sealed types is, in fact, language support for exactly doing that. So if I have some interface I, there's the syntax is you say interface I permits A, B, C. And A, B, and C are the only implementations that are permitted in the entire JVM to implement that interface I. And so right there, that gives you a way to use interfaces in a way you couldn't before, because if you have an interface, then you know that it's one of A, B, or C. All right. So that's what's in 17 already. What the next step for that, though, is that you'll be able to switch over types. And that might be preview in 17. I'm not sure. There's pattern matching for switch that's in preview in 17. And yeah, so that's not in there yet, but you have to do the enable preview thing. And that language feature is still under development. And so then what you can say is, I actually don't know what the syntax is, but I'll just sort of describe it. But you can essentially switch on the type of I, and then you can have case A, case B, case C. And since I is a sealed class or sealed interface, the compiler knows that, this implementation is one of A, B, or C. And so you can write an exhaustive switch statement or switch expression, and you don't have to write a default. So what's interesting here is that there are a few things going on, like these language features we just talked about, the pattern matching, switch expressions, and sealed classes. They all look like independent little. It's like, okay, this is a nice little feature, but who cares, But no, these are all little bits and pieces that are part of a bigger puzzle that we're going to be assembling they'll be assembling over future releases. So all of these are going to all of these are going to work together very well. As Project Amber begins to deliver more of the advanced pattern matching features.
Yeah, I mean, there's so much in the language that's 0 to n, 1 to n, but you never know what n is. In this case, with enums, with sealed classes, you can actually kind of say, hey, this is how many, and now I can iterate, I can enumerate, and I can set limits. And within those limits, I can have expectations around behavior and kind of set some boundaries where I couldn't do that before.
Yeah.
And there's no reflection tricks for bypassing this, right?
I don't think so. I forget exactly where the enforcement is. It's certainly in the compiler, but one of the things we do think about is the division between the compiler and the JVM. And so I'm not entirely sure how this is done, but I believe if you say sealed interface, sealed interface I, permits A, B, C, then all of that information is written into the class file, and the VM can enforce that because it has, it has the fully qualified type names and class names and whatnot. And so if some other class comes along, some class D, class D implements I, it actually checks the permits list. It says, oh, you're not permitted to do that. And so it throws some linkage error of some sort, probably.
Interesting. I wonder, because one of the things that sometimes does happen is you essentially back in those libraries that are unsupported or they don't want to update anymore. Sometimes you have to throw in an implementation essentially of one of their implemented classes, and then just change some stuff in there. Like that, I had to do that for some protobuf upgrades, right? Like they were stayed on protobuf, whatever it was.
Accidentally hit the wrong button. Go ahead.
So it's interesting because I guess we'll see when it comes. But I presume that there's no way, for example, to override a sealed class through me redeclaring it on my current project if the sealed class is part of a sort of like a dependency that I brought in. Stuart Marks.
I'm kind of not following you on that.
So imagine you have a dependency that brings in food.com dot, I think they put planets, right? Like that was one of the examples. So, and in planet interface or whatever, like celestial object interface declares planet, star, and black hole as part of their COID definitions, right? So if I have a project and I bring that dependency, that jar in, can I create a new Java class that is on the same package name that then decides to override planet, redeclare planet on my project?
Oh, so you're extending one of the classes that are implementing the interface.
Right. I think technically, I think that might be.
Wouldn't that be adding? Or I guess I don't.
So, all right. So let's say, okay. So let's rerun the example. So interface, sealed interface, celestial object permits. I forget planet star, black hole.
Yeah, there you go.
Yeah. Okay. So then maybe can you add a subclass of star? Answer, maybe, right? And so part of the sealed packages or sealed classes feature is whether so the presumption is that if you declare a top level class or interface that's sealed, you have control over all the subclasses. And so I forget exactly what the defaults are, but there's a way you can say that the subclasses or the implementation classes are themselves sealed. And so you can further declare your own subclasses, or you can also permit. There's actually a new declaration. I think it's the first hyphenated keyword, non-sealed. Oh. So you can declare. So for instance, yeah. So suppose I don't want you to be able to. Suppose I have, sealed class celestial object permits planet and black hole, and I don't want you to be able to extend those because, for instance, otherwise somebody's going to put Pluto into.
Black holes it's a bad idea, anyways.
Yeah, but somebody's gonna want Pluto to be a planet. It's like no. Pluto's no longer a planet, right? But stars. Oh, sure, let's make stars extensible. So you can say non-sealed class star implements celestial object. And so what that does is it allows extension of star only at that portion of the hierarchy.
Really? But then does it become exhaustive, or like how does that work then with like the switch statements or?
Well, it's still exhaustive because every extension class of a star is a star in the object-oriented sense.
I see.
Right? Yeah. Right. And it may seem like a weird thing to do, but it's also something that does occur frequently in object hierarchies, where, I've done this, an example of UI widgets, right? You might have a button, a slider, and a menu, and then you might have a customizable item. Well, what is that? Well, I don't know. So let's add a bunch of new interfaces in customizable item and make it extensible so that people can do anything they want. Mm-hmm. So anybody who wants to extend the UI toolkit would make that be their extension point
instead of just being a button.
Yeah,
I see. Huh.
Yeah, so there are a bunch of use cases embedded in there, right? So a sealed class is certainly, well, basically the theme is that it provides the object designer a lot more control over exactly when and where extension can occur. Or, and final, making a class final is too big a hammer. And in fact, it doesn't work with, it doesn't work with interfaces. You just can't, you cannot, you cannot, prior to sealed classes, you cannot restrict, implementations of interfaces. So anyway, a lot going on in this feature.
All right. And then just to round out the last of the language feature, because I don't know that it quite interplays like the first three, but the text blocks. Yeah. That's just a formatting thing, right? Like I don't have to worry about adding plus signs the end of every single line anymore. I can just write text.
Yeah. And in a sense, text blocks is a pretty simple feature. It is basically convenience for multi-line text literals. So if you can use a text blocks, it's delimited by triple quotes, and you can have embedded line breaks in it. In other respects, I mean, it's a very narrow feature, but one that will probably get a lot of use because, having a multi-line string, or even splitting a string literal across lines is a real pain because you gotta close the quote, put a plus, new line and all this stuff. So it really garbages up the syntax. Yep. And so, but in all other respects, text blocks is just a different syntax for the same string literal. So, so its type is still java.lang.string. The interning properties of string literals are all still the same. So it's mostly just syntax. I think the most complicated part of text blocks is dealing with indentation. And there's a bunch of complicated rules for how indentation is processed, which I'm not going to go through here. I think it's a little too detailed. But basically, it does the right thing. And I think the idea is that it preserves significant indentation. But suppose you go and refactor your code and you take some stuff and extract it into a different method, including a text block. That new method is probably going to have a different level of indentation than the original one. Right? So, but you don't want the actual value of the text literal to change if you merely change its indentation. And so what the text block stuff does, I think, a pretty good job of is figuring out what indentation is insignificant and is therefore not included as part of the actual string literal.
Oh my gosh. Yeah, I haven't realized that, but yeah, you're right.
Yeah.
You move it around and things do change.
Yeah, looking at the text of the JEP, it's definitely lengthwise one of the more lengthy ones, even though we describe it as a simple feature because of all of those rules. Yeah. But you can check out the link if you want to get into the rules. Well, I'm sure we'll have links to all these JEPs in the show notes.
Yeah. Yeah.
So
we'll make sure to do that.
All right. So let's move on to a different aspect of our
daily JEP.
Of our daily, yes. And this is one of my favorites because this one actually came up recently is helpful null pointer exceptions. So yeah, I realize if you write good code, you're probably not going to end up with null pointer exceptions if you're null checking and things like that, but we all make mistakes. None of us are perfect. So when you get that null pointer exception, you're used to just getting the line number, but you never actually know, well, which part of that object is null.
So
now you do.
So yeah, this was a bit of a surprise to me because, hey, I my code doesn't have bugs in it. Well, but when it does have when it does have null pointer exceptions, I always know immediately what's gone wrong. So I have to say I've kind of turned around on this. I was pretty skeptical of it. And I should give a shout out here to the team at SAP who are the real champions for this. So they actually developed this, and this was part of the SAP JVM for a long time. And it's something that they found valuable, and they wanted this, they wanted this feature to be of, service to all OpenJDK users, not just SAP users. So, hand it to them for championing this and getting this into the JDK. The interesting thing about this is, so I think Bob kind of described it already, but basically the null pointer exception message, used to just say, in the stack trace, the null pointer occurred somewhere on this line. What this does is expand on that and give you more information about it. It says, if you have a.b.c and you get a null pointer exception there, it's like, well, where did that occur? Right. And it'll say, well, null pointer exception occurred on this line because A was null. It's like, or sometimes it could be a.b was null. Yeah. So, and then of course, if you have a more complicated expression, it'll tell you like, or another one is, foo dot bar dot baz right? Yeah. And say, you got a null pointer exception because the return value of the bar method call was null, and you attempted to invoke an instance method off of that, which generated an NPE. So that's helpful because it gives you more specific information. What I found interesting about it was, this feature is almost entirely inside the JVM. And so when an NPE occurs, they actually really did some interesting analysis here, right? When they encountered an NPE, then, so the JVM is really optimized towards high performance execution. Mm-hmm. And so the first thing is, they wanted to avoid slowing anything down because of this. So when you're throwing an exception, though, basically it's like, okay, an exceptional condition is pretty much accepted as being the slow path. So they say, on the slow path, let's put some additional analysis code into the JVM. So it actually does data flow analysis backwards from the point of where the NPE was thrown, and it traces back where that null came from, and then attempts to map it to the name method calls, variable names, and whatnot in your program.
So from the bytecode, it decided to go back.
Yeah.
And oh my God.
It's actually, it's actually pretty sophisticated.
I was going to say because it felt like, again, if you have no idea how the JVM internal works, it almost feels like you just needed to do a print line on the null pointer to say oh, it's here. But I was suspecting that it was probably something that is complicated, but I did not realize that it had to go all the way down and essentially backtrace
Right. Well, and so, I think they did a really good job of this, which is, one of the concerns was, do we want all this bytecode analysis,
all the time?
Yeah. Well, one is get it off the critical path, so it's in the slow path. And the second is they actually have a bunch of, I think it's sort of design heuristics, really. It's like they cover most of the common cases, but they also make sure that the VM is not going to go into an infinite loop doing this backtrace analysis.
Oh.
So I think what they do is they make a best effort, which catches a bunch of the most common cases. So they'll trace it back. And then, I actually don't know what code would cause this to happen, but you can imagine some academic somewhere, right? Some really, really intractable, deeply nested expression that would cause a full analysis, to go quadratic or something, right? Right. I don't know. I'm making that up, but you can imagine that the analysis can get arbitrarily complicated. And one of the things they put in was to make sure it's like, okay, no, we don't want to do that. We basically step backwards until we get, some, useful bits of information and then cut it off at that point and tell the developer. And, I've been surprised because when that feature went in, I said, I'll never use it. Right. And, I have to say, I admit sometimes my code has bugs in it. And I was surprised. It's like, I would have figured it out sooner or later, obviously, but it's sort of, variable B is null. Oh,
yep.
Whoa. So it's kind of a sleeper feature. So I'm turned around on it. It's,
where it saves you, I think, is in production when it's like, you missed a case, because most of these things we end up catching testing locally or just kind of running through the most high level scenarios. And it's like, oh, okay, I can break down this statement and tear it apart so I know where the null comes from. And I'm usually there in a couple of minutes. But when it's in prod, it's like,
oh my God, you can't repoint.
Where do where do I approach this? I don't have anything in the log. Having it in the log makes that, that next patch release occur so much quicker.
Yeah. I know it's, or at least where to start, right? Like where you put your logs or where you put your defensive if statements and that.
Yep.
So no, I'm so looking forward to that because unlike Stuart, I do make a lot of.
Yeah. No, my client that moved up to 16 actually hit one of those, and it was like, oh, it's that object. That's nice.
Yeah, it is. It's one of the. It's a pleasant surprise.
Yep.
I have to say. So it's pretty cool.
All right, so let's dig into this will be your favorite one, Freddie. So this is performance features.
I know.
So an abnormal, I guess I would say, amount of action in the garbage collector space from different vendors, from things being removed, from all over the place. So you've basically got two new collectors coming in, right? You've got probably one of the more popular collectors pre-Java 8 being removed. And let's start there. So I guess the two new ones. So you got ZGC and you got Shenandoah that have been moved into, and I believe they're both ready for prime time. They're not preview at this point, right? They're both.
Yeah, I think so. Yeah. So the ZGC or ZGC, depending on what you think sounds cooler. As an American, I hardly ever say Z, so I say ZGC as a chance, as a grasping at straws to sound a little bit cooler. So that's developed and maintained by the team at Oracle in Stockholm primarily, and then the Shenandoah GC is developed at Red Hat and was put into OpenJDK, and I believe they were both experimental for a while, and I believe they've been declared to be production ready at this point. I don't know that much about the particulars of these GCs, but they're both the intent of both is to be low latency, and nobody has actually achieved a completely pauseless GC. That is a GC that has no pauses whatsoever. But so they call them low latency GCs because there are pauses in the execution, but the pauses are bounded and are very short. So I think, I mean, that's the intent of both of those.
So, I mean, like, so what are the use cases? I mean, so G1 has been kind of the go-to since you've been, since Java 8's come along. And, it's to the point where that's the default, right? But these new garbage collectors, I mean, are they usually large heap sizes? Is it, hey, regardless of heap size, I just need something that's low latency and bounded? When do I typically move away from my G1? I mean, do you have an idea what the use cases were that drove some of these?
Yeah, I don't know the particular use cases, but there are people who have, I mean, the typical one is high frequency trading. Mm-hmm. But there are typical things where people do want to make, latency guarantees. And I think in this GC space, there are these trade-offs between throughput and latency. I think this has been true for a long time. And so, and just to catch everybody up on it, all the listeners, the idea is if you have, if you have a workload to be done, throughput is get through that workload as quickly as possible. And the rate at which that work gets done, you don't care if it stops and starts or pauses in between there, as long as it gets done sooner. Yeah. And the trade-off that all of the low latency GCs make is that they actually do more work and spread it around differently. So they actually spend more CPU time, but they do that at in order to deliver more predictable latency. And so I don't know the numbers, but I think that one of the ZGC design goals is so that no pause be more than 10 milliseconds. And I think in most workloads they've run, it's usually less than 1 millisecond, which is pretty darn good.
Amazing.
And also, and I think Bob, you mentioned something important there, which is this is irrespective of heap size. And so I think what these GCs do is they've carefully tailored things so that the latency does not increase even with very large heaps.
Damn.
Yeah, so it's pretty amazing, right? So I don't quite frankly don't know how they do all this stuff. It's really quite sophisticated.
But yeah, very relevant stuff, because I mean, so if everybody was running batch loads where you just kick it off and go to sleep, throughput's all you really care about. But, a lot of Java customers are web apps, and response time at the 99th percentile matter to customers, because you don't want to be that one person that gets hit with the big GC, or maybe that's during peak load and suddenly you've lost tons of business. So low latency does have its use case in the marketplace. So.
Right. So I think that's true with the other GCs. In particular, the older one, but I think this is still true of G1, that there are cases where it will stop the world. And if you have a very large heap, it might stop the world for, longer than you want. I'm not going to name any performance figures. I don't know what the numbers are. But if you have a very large heap, then that can be uncomfortably long if you're waiting for it. And I think that's the case, right, Bob? If you're like you said, if you're just doing a batch, you don't care if there's a long pause in the middle of that. You just want to get it done.
Yeah.
But yeah, so if you're concerned about response time, if you're concerned about, responding to a message within 50 milliseconds, and, people do statistics about, percentiles of response time and whatnot, that's when the low latency stuff is really important.
No, I think, it was interesting because, for me, when working with concurrent March sweep, there was so many knobs to turn, right? Like it was just, how big you make your Eden, how big you make your generator, your your perm gem, and all these things you had to do. So when G1 GC came around, it was like, just give it the target number. We'll figure the rest of you. That was like, oh, this is nice. Now that I see that there's with the two new ones that are 10 milliseconds for ZGC. I still remember the days where we had this is just a small story. Back when I was working in the financial industry, we did have one on the very beta of what we were doing, we were generating a lot of garbage, and we had like, I think, a 2 gig heap. And it got to the point where we know that if we let it run into the 2 gig heap, that we're going to have a pause for like 1 or 2 seconds. And we actually had to sort of like, at the moment that we know that it was getting close, it's like, you know what, let's just hold off for a minute until the garbage collector does his thing. We know it's going to happen in the next 10 minutes. And then we go back to it and then keep working on it.
Call system.gc and try to kick it into happening now, or?
Oh gosh. Yeah. Oh yeah. No, but it took a little while. Like, and it was too, again, so many years ago now. Right. Yeah. But I can't believe like just the rate that they are going. And it's one of those things that it is unique for like each system is different. But if garbage collection tuning is something that you care about because, like Bob says, you're running on a web, or even if you're on algo, a high frequency, or even on your regular systems where you cannot afford a pause because things happen, like, right? Like there's circuit breakers, there's like things on top of your stack. If you have a microservice architecture where if they don't hear a response from you, then they will assume that something bad happens. Then just throwing in and playing with these GCs is just worth the time. So
yeah. So whatever happened to CMS though? Where are they now?
Well, it's now in the where are they now file, right? So you mentioned the CMS, the concurrent mark sweep garbage collector, and so that was deprecated and removed sometime between 11 and 17. I think JDK 15 was when it was actually removed. And I think there, it's like it's an older implementation, and I think that with the modern GCs, it's a question of keeping things maintained. And I think part of, you mentioned a bunch of knobs, right? I think trying to explain all the knobs to everybody and having people invest the time in learning all of those knobs is not necessarily helpful. Because I think G1, so these garbage collectors take a long time to shake out. And I think G1 was the initial experimental implementation was in JDK 7, if I'm not mistaken. Right. And so it has come a long way. And so I forget when G1 was declared production ready, 9 or 10 maybe. And
it was. It didn't go in 8. We had to wait a little bit more.
And there were some complaints about G1 versus CMS because, G1 just did not have the track record that CMS did, around JDK 11. But one of the things is that there is a team also continuing to update and improve G1. And so it's not like G1 is just sitting there and everybody's working on ZGC. At least at Oracle, it's not like that, right? So I think there is a team working on G1, and they have made continual improvements to it. Since JDK 11. And so they're not earth shattering, but, in the performance game, it's like a few percent here, a few percent there, little features here and there. Like, so there is actually a JEP about G1, which is that it will now return uncommitted memory back to the operating system, or unused committed memory. Right. So,
oh, really?
So it's one of these things where if you hit a high watermark and it allocates a bunch of memory from the OS, and then after a while it becomes unused, it'll give that back to the OS. And there are certain times where people want that. There are workloads where giving memory back to the OS is something useful, and I guess it reduces costs in the cloud as well, because your whole application ends up reducing the actual memory consumed.
Yeah.
So the G1 guys are still hard at work. I think it's much more mature now. So, but they're still finding new places that they can improve things and stuff. So if you're a G1 user on JDK 11, then upgrading to JDK 17 should get you.
They just give you some stuff for free, right?
Yep.
Nice. And then and if the one thing that I always it's good to remind, if you decided to try other garbage collectors, do remove your old CMS and G1 tuning parameters. Like they keep it's because like at some point in time it got like it was like gospel. Like these are the real parameters that you need to use, and people just keep copying and pasting them on like your startup script and never looked at them back. But yeah, if CMS is not even there anymore, so if you still have some of those, remove them. If you're going to play with different garbage collector, remove the G1 because G1 has some knobs, not a lot of knobs, but it does have some knobs. So yeah.
All right. Then to round out performance, Unix domain socket channels. I mean, is this basically bypassing the network stack on like loopback or local calls between, interprocess communications?
Yeah, well, it's one of those things where if you're in the Unix world, then Unix domain sockets have been around forever, but they never made it to Java. And because, it was always like, well, what if you're what if your OS, like Windows, for instance, what if Windows doesn't work? Well, amazingly enough, Windows has Unix domain sockets now. I'm not quite sure. I'm not quite sure what I don't know anything about the Windows API, but there's something that's more or less equivalent to Unix domain sockets. And the main thing is that, and it's amazing how much performance lore you hear over the years. One is that, somewhere in the mid-evolution of, probably in the 90s or something, I heard from some of the kernel guys saying, oh yeah, the networking stack in the kernel is fast enough that if you're on the loopback interface, it's the same speed as a Unix domain socket. So it's not worth using Unix domain sockets anymore, right? That kind of stuff. Oh. And, it goes back and forth. But, okay, so that isn't necessarily true, right? So my colleagues on the networking team, did some work on this. And so there are a few new APIs to just say, this is a Unix domain socket instead of an internet socket. But they did some benchmarks and found that, there actually is, in most systems, there is a performance advantage to going with Unix domain sockets. And also there's a little bit of a maybe sort of security, but I think if you're using Unix domain sockets, by definition, it's a local connection. Local. Mm-hmm. And, when you're using a network socket, even if you're intending it only to be a local connection, it's like, am I binding to the right address that right. Nobody on the internet can actually connect to? Is that actually going to work? Right. So you gotta be a little careful in doing that. Right. So if you're using Unix domain sockets, you get a performance advantage. And if it's appropriate for your application, you can make a stronger guarantee that you are accepting only connections from the local machine.
And these are the ones that are essentially the ones that look like a file path, right? Like /ABC/df instead of having numbers for like local loopback or anything like that, right?
Yeah. So Unix domain sockets, at least on Unix, where I'm familiar with them, right? It's actually an entry, it's actually a node in the file system. Yeah. No, and that's interesting because a lot of the tricks between like IPCs, right, in the process communication, like we know that we actually have some like C++ pockets, and they will use Unix. They use the Unix domain sockets to like do IPC between those applications. And I know that is something that we wanted to tap from the Java side, but it was hard because there's no support for that kind of like sockets. Yeah.
So this opened the possibility of that. So it's a lot of it is also like for us it's IPC. In the process communication that makes me very interested on this.
All right. I think that rounds out the performance section. And now we get to your special section, Stuart, the deprecation section. So that's right. What do we not have anymore is now that is where we're at.
Like, what kind of reflection?
Yeah.
So Nashorn's gone?
Yeah.
Let's start with that, because that used to be something I used.
Yeah, it's a little bit of a sad story, the whole thing with Nashorn. Because I think it started off as a proof of concept to say it's like this is when rewind several years. Remember when Invoke Dynamic was fairly new?
That was 7, right? Yeah.
Well, I think it was introduced in 7 and it just kind of sat around for a while. And it wasn't until 8 or 9 that people really said, you can do so much with this thing. And then the JVM languages started using Invoke Dynamic for a variety of things. And so I think initially one of the ideas for Nashorn was that they create a JavaScript interpreter or runtime that makes heavy use of Invoke Dynamic to make it go really fast. And I think it was successful in that in as much as it was a replacement for Rhino, which was the old JavaScript. I guess is that Apache, the Apache JavaScript interpreter?
Yeah, no, they dropped. It was just like a drop-in library that shipped with the JDK.
Yeah. So the JDK has always had a scripting extension API. And so, there's this namespace thing where you say, I want an interpreter for JavaScript and, org.apache. something. That's how you loaded Rhino. And then you could, talk to it that way. And so Nashorn slotted into the JVM in the same way. So you could still call it from scripting, using the scripting API. And so it was in terms of showcasing Invoke Dynamic, it was a big success at that. It was really fast. It was not, the guys who worked on it, pretty smart guys, thinking about language runtimes. And so, they'd pull in some JavaScript, and of course they had an interpreter. And then, for certain classes of things, they would spin some bytecodes and, do an Invoke Dynamic. And, and then the big thing about Invoke Dynamic was that once the JIT got its hands on it, then it could inline a bunch of stuff and do all the JIT style optimizations on that. And so they had specialized. And so one of the things about JavaScript is that it's dynamically typed. So if you have an expression or a function call on something, you don't know what type you're operating on by looking at the source code. But the way people write programs is, well, if I'm calling this function, it's 99.999 or maybe even 100% of the time it's being called on a string. And so what they did was they said, okay, we'll do an Invoke Dynamic on that and have the bootstrap method. It's like, oh, this is a string. And then they'd return an implementation that was specialized for string. And one of the things about Invoke Dynamic is that if those assumptions change, then you can undo the optimizations. And so that's really cool. So the common case you handle really, really fast. And then if there's a special case, then it de-optimizes it. And this is all the fairly standard JIT compilation techniques at this point. And actually it's pretty funny. Here's a little story for you. One of the things they did is, when they recognized certain code, they would compile it optimistically, because the way people write most code, and including JavaScript, is that it's very highly stylized. And so if you're doing certain constructs certain ways, you can generally assume that it's doing something fairly conventional. And it's only pretty rare that people do some weird things. It's like, I'm going to be passing strings a whole bunch of times to this function, and 0.01% of the time I'm going to pass a number. Right? That kind of doesn't happen. And so the way they made the system go fast was to compile things optimistically. And so they assume that, code written in a particular style would be doing this. And so they compile it with that way, but then they leave some checks in. And if their assumptions, they'd validate their assumptions. And if their assumptions were valid, then things would go fast. But occasionally, their assumptions were not valid. And so what they'd have to do is back off and recompile some stuff. And so the way they had an internal signaling mechanism, which was to throw an exception, and the exception type was the unwarranted optimism exception.
That is the actual name?
Yes, that's the actual name. I bet.
That's amazing.
Yeah, so that's pretty funny. I always got a tickle out of that.
That must have really slowed things down, because now you've got an exception and you're recompiling and you're.
Well, yeah. So if you're switching between numbers and strings, then that's a problem. But again,
you deserve what you get.
You get what you get. You don't get upset.
Yeah, right. So I think the problem though is that I think they brought up a very good runtime for JavaScript on the JVM, but there are a couple things that conspired against them. I think one was that the JVM is not ideal for JavaScript. It really is geared around Java, and so any of the JVM language folks, if you talk to them, what they have to do is they use bits and pieces of the JVM and try to dodge the pieces of the JVM that are Java specific. And so that's the game that they play. And that's also true of JavaScript. And so the upshot though is that there are other JavaScript implementations out there that are tailored towards JavaScript. In particular, there's the V8 VM and the Graal VM, the polyglot stuff from on the Graal side, that's tailored towards, a dedicated JavaScript runtime, whereas, the JVM is the target, and that is still very Java centric. So they're kind of at a performance disadvantage that is very, very difficult to overcome. And then the second thing is that the JavaScript language itself was evolving very, very fast.
Yeah.
And it became clear that trying to keep up with this was not, and keep up with all the language evolution and keep it performing fast it wasn't providing the value that we wanted to have it built into the platform. So we said, it's not that it's bad technology. And here's the thing. So from the standpoint of Java SE, the Java Standard Edition, Nashorn has been was it ever part of Java SE? Actually, it was part of the JDK, but having it be a standard part of the JDK, we said, it's not worth keeping it up to date and trying to keep up with, high performance as alternative implementations. And so we said, okay, let's deprecate it and remove it from the JDK. But that doesn't mean that it just disappears. And so there's still a Nashorn project on OpenJDK. So here's where we have to split hairs a little bit. So there is the OpenJDK project, which is an umbrella for a bunch of different projects that are all open sourced. And one of those projects is the JDK itself, but there are a bunch of other projects. And one of those projects is Nashorn. And so there's still a Nashorn repository out there. It doesn't get as much activity as it used to, but actually one of the original team members, Attila Szegedy, is still doing stuff on it. And I think he hasn't. I think last I looked, there were some things that he still needed to do to make it JDK 17 compatible, but he's been keeping up with some of the stuff, and people still use it, and so anyway, so it's still out there. It's not like it's dead. It's just no longer part of the JDK.
Doesn't ship with it, so I can pull it in as a dependency and use it that way. Yeah, and
exactly.
The points you brought up are the reasons why I always struggled with it, is just keeping up with the JavaScript language runtime and all the changes to it. You drop in a brand new version of a JavaScript library, and there'd be things you'd have to tweak around with it to get in standard with the version that Nashorn was on. And it was actually, it was a holdover from Rhino. And I was looking up Rhino. I'm like, is that really an Apache? It's Mozilla. So it was an open source foundation, but it's Mozilla is where Rhino came from.
Yeah. So sorry.
No, it had me thinking, I'm like, did it really come from there? I used both of them and kind of the same problem. But now you've got implementations on Graal where you can tap into those other runtimes a little bit more natively, I suppose.
Yeah, I do have it's kind of funny. We have a couple of Java 11 projects that when we start up somewhere on the code base, because when this was slotted for deprecation, somebody actually did system out print warning. This is scheduled for the whole it's not even on the log system. It's just there. And every time I run this project, I always see it going from the standard out. It's warning, Nashorn is going to be deprecated.
Yeah.
and it caught up to me. And now I need to like doctor, it's gonna hurt. I gotta dive into like the next week and then see who it's probably. I'm sure we're not actively using it, but it's one of those where there's a library at some point in time that somebody created that brought it in, and I just now need to go and sort of like unfurl that see who is actually calling it, who is actually adding it as a dependency. But,
so
JavaScript, you gotta keep
JavaScript
on top of these dependencies.
absolutely. And JavaScript's a little bit out there, but the next thing is something that you probably shouldn't have been doing for years now, which is applets. So they're gone now, right? That's official.
They're gone.
And so is the security manager related to them.
Well, okay, they're not gone yet. Right. So in JDK 17, both applets and the security manager are deprecated for removal. I think applets, I think, we've heard the applet story play out for a long time. I think applets were almost, I think applets were deprecated, but not for removal all the way back in Java 9. And even at that point, applets were basically dead because browsers were desupporting them. And so we did have some customers who were, maintaining their own old versions of software and this and that, and they still wanted to run applets. And so we kept applets around for a little bit longer and said, okay, this time for sure, deprecate for removal. So I actually don't know when they're planning to remove it, but
the warning is out.
For JDK 17, notice has been given. And so that I think should not be a surprise to anyone. The security manager deprecation for removal, I think, did catch a lot of people off guard. And maybe I should have been surprised, or maybe I wasn't. I don't know. I think it's interesting. I guess from my standpoint as Dr. Deprecator, right? So the security manager deprecation created a fair amount of controversy. And from my standpoint as Dr. Deprecator, I think it really shows that the deprecation for removal is being taken seriously now. So that's good, right? Because like Freddie, what you were saying before, it was like, deprecating, that doesn't mean anything. Nobody pays attention to it and stuff, right? Well, so I think this is success, right? If we deprecate something for removal, people take that seriously and they react to it. And so I think that the security manager thing is, if you look at that technology, well, first of all, I mean, it was primarily built around applets as the use case, right? If you remember way back in the 1990s, the idea was you have a JVM running as part of or a subprocess of your browser, and you download an applet, and so that loads some Java code into your JVM. And so now you have the trusted parts of the JVM and you have an untrusted part, which is the code you get from the applet. And so, security manager is kind of a shorthand for this internal partitioning of code into, different levels of trust, or code with different privileges running in the same VM. And so applets were the primary use case. Over the years, there were a few other things that use that. Like there were things that would send class files around. Like there was a little bit of that in RMI. Kind of an extension of the RMI model for things was this project called Genie. I don't know if you remember that. That was another 1990s distributed.
That's back in
remember that.
Yeah.
No.
Right. And so the idea was, it's like everything was dynamic. You'd load classes over the network, and if you loaded classes over the network, you'd have a sandbox, or you'd have an area of your VM that had reduced privileges, and that's kind of where the security manager was intended for. And so the first thing is we haven't seen any use cases for the security manager for I don't know, over a decade. I mean, nobody, fact is nobody builds distributed systems that rely on this sort of these privilege models. And it's been a maintenance overhead, and very, very few people run with it. So I was a little bit surprised when there was so much controversy when we announced we were removing it. I know the security team had been doing a lot of discussions with customers. They'd done some surveys. I've talked about it at conferences and stuff. But I think that people kind of didn't believe that we'd go so far as to actually remove the thing. So anyway, so we laid down a marker that we want to remove this thing, because I think the fundamentals are that this is not the right model for how to run distributed systems. It's having that, specifically having different hunks of Java code in the same JVM that have different privileges, right? And so I think over time, what we found is that, remember, the old thing was that you used to have a computer that would have a bunch, a big computer. And if you wanted to do more, you got a bigger computer. And, you had many, many, many JVMs on it. And so so the idea of having a sandbox inside of a JVM was something that was, it never got much purchase on the server side, but I think as a concept, it was a little more valid. Nowadays, people don't talk about a computer, right? You have the cloud and you have things running in containers and everything is virtualized. Yeah. And so if so people talking in the cloud, everything is connected to everything else. And so it's like, what if there's a fault, or what if there's a security breach? People have this concept of blast radius. And so you limit your blast radius by putting things inside of containers. Yep. And then locking down the container itself. You put a minimal system image on, that sort of stuff. And so I think that's the modern approach to security these days. And so having internal partitioning inside a single JVM instance is really, it doesn't fit with that anymore. Yeah.
No, that makes sense.
So that's the basic rationale. If you look at the JEP there's a very long rationale that I think kind of explains what I just said. But if you want the details, certainly go there. You had another note here about, so this is, I think the main thing is that in Java security, it's a little confusing, because when you talk about Java security, there's a whole bunch of things that all fall under the umbrella of security, but they're actually all different. So for instance, there's a whole scheme for crypto providers in the JDK. That's completely separate from the security management. Right. That stuff is not going away. That's very important. Keeping up those algorithms up to date, that's very important. So we're constantly going through that. Another area that also falls under security is secure communications, like TLS. And of course, that's, related to certificate verification, and also, relates to all those secure algorithms. That stuff is all staying there. We're obviously fully committed to that. When we talk about the security manager, we're specifically talking about the internal access privileges, where different pieces of code in the same JVM have different privileges. Yep. And, the canonical example of that was applets. And as we just talked about, applets are going away.
Not a thing. Yeah. And I think that I would be surprised if some of the hemming and hawing over it being removed is from misunderstanding what exactly. It's just the security manager. Is that the thing that manages all the security? No. Look into it. Read the JEP, and you'll understand that this is a small aspect of what you're probably actually, or it's not a non-factor in what you're actually using the JVM to secure your code with.
Yeah.
All right. So it's finally happening. We're strongly encapsulating the JDK internals and enforcing it by default now. So this is what they always said was coming with Jigsaw. Now it's here, huh?
Yeah.
By default.
Right? Yep. Yeah. So with JDK 9 and Jigsaw, there was the, when people tried to use reflection over the internal JDK classes, they would get that warning message. And, many blog posts and GitHub projects were dedicated to figuring out how to shut that off instead of having people fix their code. But anyway, so there was a switch that controlled that, which was, what was it? minus illegal access equals, permit, permit, debug, and deny, I think were the values. And so there's been some evolution of that. I think it was in JDK 16 the default changed to deny, but you could turn it back to permit. And then in JDK 17 they removed that entirely. So there's no more illegal access option on the command line.
Oh boy.
Yeah. And it's kind of interesting because I would have thought that would have been more controversial, but maybe, I mean,
give it a couple months.
Really wait for an adoption to pick up. Why doesn't this work anymore?
Well, but it's funny because there's a JEP for it, right? And so we don't really think this way, but it would, almost as if we slipped it in behind the security manager thing. But no, I mean, this is something we've been planning for a long time. I guess the thing is though, that's, there are still ways into the system. It's just that this is just, even though the illegal access option, command line option is gone, there's still other ways into the system. And so in particular, unsafe is still there. So you can still go in if you have code that relies on unsafe, and the fact is, with unsafe, you can do anything. You can still load and call native code. Native code can do anything. What else is there? What people often do is, the primary use case for this was, if you reflect on a class somewhere, in particular JDK internal class, then it's like, oh, there's this field in here I want to set, but it's a private field. So I'll just call set accessible true on it. And that's what this is, that's what this is aimed at. And so by default, you can't do that anymore. And you can't, and you can no longer throw the big switch, which is illegal access equals permits. However, there still are the module options that you can put on the command line, which are add opens. And so if you have a particular module, including ones in the JDK, that you want to allow your code to get reflective access to, you can still use, add opens, Java base, blah, blah, blah. And so in particular, and it's still useful to have that as a trapdoor, right? So for instance, I build my own JDK, but sometimes I want to write a test program that kind of pokes around in the internals without actually having to rebuild the JDK. And so for diagnostic purposes, I throw add opens, java.base, open it to everything on the class path, and then, muck around in there with reflection just to see what happens. So I think certainly for diagnostic purposes, I do that. I think the point though is that if you're in a production system and you find yourself doing add opens all the time, then, and this is kind of the point of it, it's a signal to you as, whoever is deploying the system, that there's a bunch of code that you're using that is relying on either, JDK internals or somebody's module internals. And people feel free to modify their internals at will. So, and including the JDK. And that's actually, that's something that has happened over the years, which is, inside the JDK, this happened. Somebody had a list of something, and, this is, private field inside the JDK. And they said, actually list is insufficient. This needs to be a map because we need to associate some values with it. So they changed the type of some internal field from a list to a map. And that broke a bunch of code. Yeah. Because unbeknownst to them, there was some code out there in the wild that reflected on it. And they said, oh, we want this list of things. So we're gonna, do set accessible, get this value, cast it to a list, and then do stuff with it. Yeah. And, that cast broke because it's not a list anymore. It's a map.
That is bold.
Well, yeah. And so that's the real problem, because with, in JDK 8 and earlier, without this, in the absence of encapsulation, the whole JDK was a surface area for people to form dependencies on. Yeah. Yeah. And there have been cases where, we put in some change, and then, big, high revenue customer comes in and said, hey, you broke our code. Oh, well, that's not part of the specification. It's like, we are a paying customer and you broke our code.
Undo it.
Yeah. So, so I think, and then of course they're paying customers, but then there's also all the people who, we have podcasts, we have articles, we have conferences and stuff, but we still reach only a minority of all the Java developers out there. Mm-hmm. And so I'm sure there's stuff that we never hear about where somebody, way off in some shop that we've never heard of, his code is broken because he actually he did, or more likely he inherited some code from his predecessor that went in and reflected on some stuff in the system. And they said, oh, yeah, we shouldn't be doing this, but I'll fix it later. Well, years later, it's, his poor successor is responsible for this. So anyway, yeah, so this is the latest step in the evolution of trying to make sure that the internals of the system are well encapsulated.
No, it's going to be interesting because like for what I see, right? Like the two cases that I'm worried about, like for example, libraries like Netty, they got better, right? They're sort of now the way that they sort of start by poking around, see like, can I still do reflection? And there's sort of a path where it's like, oh, I do reflection with legal access and it let me do it, so I'm going to go this path. Or it did throw, or it didn't let me do it, and then I go this path. But that is newish on Netty, right? Like if you happen to be on an older library of that, and Netty is one of those where major versions that include even within minor version upgrades, they do change how they create the listeners and their apps, like they're sort of like the interfaces change a little, not a lot of change, but enough change to be do not be a plugin replacement saying, I just want to iterate to the latest native version. And so that's one of the cases that I'm going to be jumping in or driving into corners. Like I'm also dig the libraries to the later ones because I know play well with 17. The ones that are hard is that, believe it or not, there's still people out there that use WSDLs and XML, and those libraries are like their maintainers have moved to a better, like we forget this, we're just moving on. and these libraries sometimes are like essentially they're not quite abandoned. Well, they're a little bit abandoned, and they were created back in Java 7 days and really not being updated. And those could be more sort of like harder, because what will mean is like you need to move to something like another sort of like XML generator or whistle generator, not the standard XJC that you were using, like from 20 years ago, right? So these are the interesting parts that I'm gonna see how, and now because it's the illegal access is to change the scope of, like I wonder like what is not permitted, any type of changes into the any type of like I guess scope changes or any reflection in general.
So it was okay. So the illegal access argument was basically just about JDK classes, and so it was actually a fairly firm line that was drawn. So what they said was, in JDK 8, there was JDK 8 had a certain set of packages that were considered part of the JDK, and in practice, because there was no encapsulation, all of those were open to reflection and set accessible, which is what they call deep reflection. Okay, so in JDK 9, there was so many other changes in the system, and various changes were, various packages and stuff were added, in particular in support of the module system and a bunch of other stuff. So what they did was, for illegal access permit, they took the list of packages, the list of internal JDK packages from JDK 8, and put those on a special whitelist. Mm-hmm. And that is what the illegal access option controls. So new stuff that was added after JDK 8 was the set accessible was never permitted.
I see.
So it was specifically targeted at the legacy applications that tried to do things back from the JDK 8 era and earlier.
Mm-hmm. Mm-hmm. All right. I might be working a little bit on making things on Silicon 17 then.
Yeah, especially if something hasn't been updated since JDK 7.
Yeah, no, I've been warned. I knew it's my own hurt. And I guess there's one last on this list for deprecation and platform. There's one last thing to wrap it up.
So this is a little more fun. I mean, everybody talks about the strong encapsulation is like take your medicine, right? And it's it's pain now, but it's an investment in the future. And so this is a more forward-looking, more pleasant investment in the future, I think. Although it is still taking something away. This is all related to the Valhalla stuff, and so. So Valhalla is, I mean, originally it was, value types and now they're called primitive classes. But the idea is that, value types don't necessarily get allocated on the heap. What that means is the JIT can allocate them somewhere else or do scalar replacement and just load them in registers and all kinds of fantastic optimization. But what it means is that they no longer have identity of their own. And prior to Valhalla, every Java, every piece of data in Java was either a primitive or it was an object, and all objects have identity. So if you said, if you have a class foo, if you say new foo, you get a reference to a brand new foo object that is not equal to any other object in the system, which is a pretty powerful statement, but that's the essence of identity. Mm-hmm. And so Valhalla wants to fundamentally change that proposition. And as part of that, we want to take the boxed primitives like capital integer, capital double, and those guys and turn them into value-based classes. And so, so a few years ago, we deprecated not for removal. We just deprecated the constructors for those. So we said, there's no reason to create a new integer. So if you say new integer of 17, for instance, you get a new capital integer object, but don't do that. You should either use integer.valueof, which would return you an object from the cache if one was available, or you should just let autoboxing do the job for you.
Right.
And most people just use autoboxing. And under the covers, autoboxing does value of. So there should be very, very few places where you should actually call new capital integer. Because it's like, you're going to use it as a value. You don't care that new integer 17 is going to be a different object from the next time you call new integer 17.
Right.
You really shouldn't care, right? So now the Valhalla guys are going to move ahead and press harder on this. And so what they're saying is we are now deprecating for removal those boxed constructors. Yeah. And so deprecation by itself only causes compiler warnings. But otherwise, if something's deprecated, it behaves just the same. But they're being a little more aggressive. There's actually some machinery in the compiler now that does some special things, like one of the things about having an object with identity is that you can do things like synchronize on them. Right. And if you have multiple threads and you want them to synchronize against each other, they need to synchronize on the very same object. That's the only way synchronization works, right? So if capital integer loses its identity, then it doesn't make sense to synchronize on an integer, because how do you know if it's the same integer or a different one?
Oh my gosh. You can be synchronizing across like things that you didn't even want to synchronize on.
Yeah.
Or if the value of it's just, hey, there's just one, you're just getting the same thing from cache. So block all the threads.
Single threaded.
Yeah. And then there's some various puns you can do. So you can say integer value of 17, and you get the same instance of 17. But if you say integer.value of 1,000, well, we happen to know that, and it's actually specified that the cache is not that big. And so if you say value of 1,000, you're actually going to get a different instance. So it depends on the value, right? And that's
just
basically just the source.
I know, right? Like,
just don't.
It's just don't. Exactly. Please. Just don't do that. That's basically just a source of puzzlers.
Bad developer.
Yeah.
Like bad developer.
Right.
Don't do that.
Right. So the compiler will now issue warnings if you do things like synchronized on one of these primitive types. Yeah, and there's actually some machinery in the JVM where JVM knows all the types, and there's special bytecodes for for taking locks on objects, and so the JVM has been taught about this and can even issue warnings and even JFR events if you do something like try to synchronize on one of these value objects. Yeah. So the Valhalla guys, I mean, they're still working primarily off to the side. They're still evolving their whole model, but they're making progress, and so things are starting to come into focus now. And they're saying, okay, here's what we want to do to pave the way for some of this stuff to get into the mainline JDK. And part of this is essentially trying to migrate old code away from these really old, obsolete idioms and bad programming practices and stuff, because these things are going to change in the future.
Yeah, I mean, again, they were okay at the beginning. It's just that language has evolved. We know exactly how we use them or what makes sense to do now. So that's going to be fun.
Looking forward to paving the way to that. So watch those warnings.
Yep. Yeah. So we'll see.
If you get them, you're maybe a bad person.
Yeah. No, it's so funny because
synchronizing on a Boolean.
I used to ignore them a lot. Now it's more of like I do take a peek. It's like, what is it complaining about? And they make a sort of like a hard, like sub decision. Maybe I won't deal with it right now. But they are. We should pay more attention. These aren't
stylistic warnings. These are seriously your stuff is going to break. It's getting more serious. But that's a good thing. So
yeah. So it was always bad style, but always you can't mandate style. You have to have a style checker to do that. It's like, are you really locking on a string? It's amazing what people do.
Yes.
Yeah.
That it has happened.
Yeah. Mm-hmm. So string actually is not going to be value based. These are basically, this covers just the box primitives.
Mm-hmm. Makes sense.
But yeah, locking on a boxed Boolean. Wow, that
is.
I wouldn't be surprised if there's some code out there that is doing that though, because
if you can, somebody probably has,
somebody's going to do it. Yeah.
Yeah. No. The constructors seem like something that somebody who just starting the language will do, but hopefully nobody does. Or as you learn that you don't need to do that, then hopefully you don't do it anymore. But yeah, all right, man, that was a lot, but great.
Yeah, well, three full years of development, right, with the 6-month releases, right? That's what we got from 11 to 17, and it's this pattern, right? So each release, it's like, there are a few interesting JEPs in here and stuff, but you add it up over a few years, there's a lot of stuff going on. And actually we could have gone on for at least another hour because there's so much stuff that we left out.
Oh yeah.
Probably went on too long as it was, but it just goes to show how much activity there is.
We can keep talking with you forever, Stuart. It's always interesting. But no, this has been great. And I think like for people, give it a shot, give it a spin on 17. There's some very, very good stuff in there. Some things that you're going to get for free, some stylistic changes that are coming that help just structuring your code. And this is all in preparation for like Project Amber and others that are coming, on a 6-month release cycle. So this is going to be even funner as we go on. So yeah.
And as Brian is fond of saying, we have a very deep pipeline of stuff. There's lots of stuff coming in Panama, Loom, and Valhalla, of course. In addition to more stuff coming in Amber, and there's some stuff going on the library side. I have like 5 irons in the fire, and I'm not really. I know I have so many things going on all at once, but they're all making slow progress. So one of these days I'm going to pop something out that's.
We should talk about your let's do that. Okay, we should talk about like the changes that are coming because you own the collection space and a lot of internal libraries, and I know that there has been like nice incremental, not necessarily like JDK. They're not jets, right? Like they're just like every new release, there's new stuff in there that I've been using, like list off and other things that are in mutable lists. Like it's like, oh, now we have them, and it's like I'm just gonna use this now. But we should do that one just about collections and all the stuff that you work on. So.
All right. Well, one of these days, when things get to an appropriate point, we'll all right.
You're always welcome to come here, reach more developers on this platform, Stuart. We always love to hear from you, so.
All right. Thank you.
And I think with that, we're done with this episode of Java Pop House. All right. This is Freddie signing off.
Thanks so much for joining us today, Stuart. This was awesome. Thanks for the knowledge. Bob signing off.
Thanks for having me on. Pleasure to be here. And everybody go out and give JDK 17 a whirl. Thanks a lot.
Oh, yes. I have the books now. All right.